Welcome, this is the IM2 video lecture on greatest common factor, part 2. The learning target is the same. It's for you to understand how to factor. The success criteria are the same as part 1. You need to find the greatest common factor, and you have to be able to factor using the greatest common factor. I want to clear up some things that you might not understand from part 1. First is the vocab. Let's go back to like 5th grade when we learned multiplications. In this multiplication problem, we say 5 times 4 equals to 20. The 5 and 4 are considered factors. 20 is considered the products. You have to understand what is a factor and what is a product first of all. You could also reverse the problem. You could say 20 is equal to 5 times 4. Here, we can say that we have factored 20 into 5 times 4. Right? That is the idea of what factoring is. Now, if the question says to factor a polynomial, you have to break up into the parts that multiply to make it. Like 20, the two parts that multiply together to make it was 5 times 4. Same thing here. Let's say x cubed plus 4x squared. What are the parts that multiply together to make it? In this case, it would be x squared. We say that we have factored x cubed plus 4x squared into x squared parentheses x times 4. Like before. So that is our answer. What we're pulling out is x squared, and that is considered the greatest common factor. X squared times parentheses x plus 4 will get you that. So we would say that x squared is a factor, and the parentheses x plus 4 is another factor of the original polynomial. So these are the vocab. I want you to make sure you understand what is a factor and what is a product. Now, this slide will show you how to factor using the greatest common factor. Here's the polynomial, 15x cubed plus 10x squared. The first thing you need to do is find the greatest common factor. To do that, you have to expand each term out and circle the variables and number that they have in common. The first term that you have is 15x cubed. That can be broken down into 5 times 3 times x times x times x. 5 times 3 will multiply to make you your 15. X cubed comes from x times x times x. Notice these are all multiplications because these are the factors. Let's look at 10x squared. That can be broken down into 5 times 2 times x times x. Now we circle what they have in common. They have one pair of 5s and one pair of x's. So we can say the greatest common factor is 5x. The GCF is the variable and number that they share together. That's why we circle it. So they share a 5x in both terms. So we go back to our equation and we want to make sure also look at what you have left over. So after you factor the 5x out from the first number, what is left? I underline it. 3x times x. So we would say 3x squared is left. What about the bottom? What is left here? 2x. We would say a 2x is left. All right. So let's go back to our polynomial. In factored form, it would look like the GCF, then parentheses, what is left over. The factored form is made up of the GCF and the term that are left. So the GCF in this problem, we label it, was 15. No, sorry, was 5x. And what is left over goes inside the parentheses. We already wrote what was left over. The first thing that was left over was the 3x squared. And the second thing that was left over was add 2x. Here you go. This is how you factor completely using the GCF. If some of you need help down here on how to expand it, I gave you a cheat sheet. So 5x can be broken down into 5x, 5 times x, 20x can be broken down to 2 times 2 times 5 times x, and so on and so on. What's in blue is what 5 to the 5th power can be broken up into. Oh, there should be one more x here. There should be one more x here. All right. There should be one more x here. 1, 2, 3, 4, 5. Yeah, there should be 5 x's here. Right? 5x to the 5th power is not equal to 5x. Make sure you understand that. All right? So this is a little cheat sheet to give you reference. All right? Okay. Now, let's look at the common examples. You need to be able to do these. Let's look and do each one together. So the first one, we have to find the GCF. And so the first term is 5x. So let's expand that. That's just 5 times x. Then we have 35. That can be expanded to 5 times 7. We want to circle what they have in common. They have a common 5. So we would say the GCF here is equal to 5. Now we also want to underline what is left. So we would say x here is left, and a 7 here is left as well. Right? Now we put it in here. Remember, we have the GCF, which is the 5. Then we have the parentheses of what is left over. What is left over here? Right? What is left over is an x. Look at the minus. Minus 7. That is what's also left. Right? There you go. Second problem, 3x squared plus 27x. Again, find the GCF. Okay, that is 3x squared is equal to 3 times x times x. 27x can be broken down into 3 times 3 times 3 times x. Let's circle the numbers and variables that they have in common. So they have one pair of 3 and one pair of x's. So we would say that the GCF is equal to 3x. So it's going to be 3x here. Then let's put a parentheses around here to show what was left over. What is left? X is left. And on bottom, 3 times 3, a 9 is left. Okay, so what is left? An x plus 9 is left over. Number 3, let's find the GCF. So it is, ignore the negative for right now. 3x squared can be broken down into 3 times x times x. The 60 can be broken down into, let's say, 3 times 2 times 10, which is just 2 times 5. Right? 6 times 2 is 12 times 5 is, yeah, perfect. Okay? Let's circle what they have in common. Oh, they only have a 3 that was in common. So we will say the GCF is just 3. So you can just write a 3 here. Don't worry about the negative for right now. So what is left over here? Well, we have an x squared that is left. And on the bottom, 2 times 2 times 5, which is 20, is left. All right, so we put the parentheses here. We have an x squared here, but remember, you see the negative? Make sure you bring down the negatives, right? Add what is left from the 60, which is a 20, right? Remember, what's inside the parentheses is the terms that are left. All right, let's do the last one. Let's find the GCF first of all. Let's see, we have 12x squared y cubed breaks down into 2 times 3 times 2. Okay. Ooh, do I have enough room? Let me clean it up. All right. I was squeezing the problem, so let's do it right here. So GCF. So 12x squared y squared can be broken down to 2 times 2, which is 4, times 3, which is 12. Okay. Times x times y times y. The bottom, which is 32, xy cubed. 32 is 2 times 2, which is 4, times 2, 2 times 2 times 2, 4, 8, 16, 32, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, good. Times x times y times y times y. All right, I know that problem is a little bit difficult. Don't worry about it. Okay, you have a 2 here. You have a 2 here. Oh, you have one pair of x's here. You have 2 pairs of y's down here. Perfect. So your greatest common factor, 2 times 2, which is just 4. X, one pair of x, and 2 pairs of y, so y squared. So we would say the greatest common factor is 4xy squared. Let's see what was left over. Okay, parentheses, parentheses. What is left over here? A 3 plus what is left over here? 2 times 2 times 2, which is 2 times 2 is 4 times 8. So that's 8 times y. There you go. That's how that one is. Good. So the practice, essentially the same thing. So let's just do that. The greatest common factor, 6x, can be broken down into 2 times 3 times x. 24 can be broken down into 2 times 2 times, this is what 2 times 2 is 4 times 2 is 8 times 3. That makes 24. Yeah. Again, don't do this in your head. You could just use a calculator. Okay. All right. And that's it. Let's circle what they have in common. Oh, you have a pair of 2's and you have a pair of 3's. So the number 6 is what they have in common. 2 times 3 is just 6. So 6 is what they have in common. All right, let's see what was left over. That's in the parentheses. So an x is left. I can write it right here. X is left. 2 times 2, which is 4, is also left. So what is left? X. And do you see the minus? Do you see the minus right here? Minus. So it's minus. What's left from the 24 is a 4. Okay? Because remember, when we pull out the 2 and the 3, a 4 is left. Good. Let's do the next one. We have to find the GCF. It is 12x squared. That can break down into 2 times 2 times 3 times x times x. Then we have 35x can be broken down into, let's see, 7 times 5. Yeah, times x. What factors do they have in common? With just the x, so we can just write the greatest common factor is just an x. So we write an x here. The parentheses is what they have left over. Parentheses is what they have left over. Let's see what's left over here. 2 times 2 times 3 is 2 times 2 is 4 times 3. 2 times 2 times 3 is 12. Times x would be a 12x is left. Okay, good. And the bottom 35 is left. So we can write here a 12x. 12x plus 35 is what you have. Good. Let's do number 3. And GCF. Okay, 5x squared can be broken down into 5 times x times x. 20x to the power 4 can be broken down into 2 times 2 times 5. Is that right? 4 times 5 is 20. Yep. Times x times x times x times x, because there's x to the 4th power. Let's circle what terms they have in common. So you see a 5 here. That's one pair. Then you have an x, which is in other pair. Then you have an x, which is in other pair. So the greatest common factor is 5x squared. So we pull out a 5x squared here. And the parentheses is what they have left over. So the first one, oh, what's left over? Just the number 1. Not 0, a number 1. Minus what is left over here? And x times x, which is just x squared. All right. Number 4, a little bit difficult. So let's just make room here in GCF. 9x squared y cubed can be broken down into 3 times 3 times x times y times y times y. What about the number 27xy can be broken down into 3 times 3 times 3 times x times y. Let's circle what they have in common. They have a 3, a pair of 3s, a pair of 3s here, a pair of x's here, and a pair of y's here. So 3 times 3 is 9, one pair of x, one pair of y. So 9xy would be the greatest common factor. About here is what is left. So what is left over here? X times y times y. So it's xy squared, because you see how there's two y's here, plus what's on bottom here? Just a 3. So it's just 3. Okay, there you go. Those are your answers, right? So these are all your practice problems. There's more problems here. If you would like to practice, I can give you the answer, okay? Try it first. Number 5, the greatest common factor was a 10. What was left is a 7 minus x. Number 6, the greatest common factor is x cubed, y cubed. What is left over? Parentheses 1 minus y squared. Number 7, the greatest common factor is an x cubed. What is left over on the inside is parentheses 6x squared minus 1. Number 8, the greatest common factor was x. What is left over on the inside is 6x plus 7. Number 9, the greatest common factor was an x squared. What was left over? You have a parentheses x y to the power 4 minus 1. Number 10, you could pull out the greatest common factor of 9. Inside, you have a negative 1 plus 5x cubed, which is left over as well. Same thing for these problems. Number 11, the greatest common factor was an x. What is left inside is an 8x plus 3. Number 12, the greatest common factor is xy cubed. What is left over is x to the 4th plus 1. Number 13, what is the greatest common factor? 2x squared. What is left on the inside? Negative 10 plus 3x cubed. 14, the greatest common factor is a 2. What is left over on the inside is a 2x plus 5. Number 15, the greatest common factor was a y. What is left over is a y to the 4th power minus x to the 2nd power. 16, the greatest common factor is a 3x, parentheses, what is left on the inside, a 10 minus 9x cubed. All right, so there you go. Hopefully that helped you. And that is how you factor by using the greatest common factor.